We're going to go ahead and get started. So today's lesson is on interpreting rate of change and slope. This is lesson 5.3. Your EQ, how can you relate rate of change and slope in linear relationships? You have 4 I can statements that we're going to be touching on in this presentation. I can show that a function is linear by identifying constant change in x and y. I can find the average rate of change given ordered pairs, a table, or a graph. I can interpret the average rate of change for a real-world situation. I can describe a function as increasing or decreasing based on a graph or a table. All right, and some of the vocabulary we want to make sure we're familiar with for today is rate of change. It's a ratio that compares the change in y to the change in x. Okay, and then rise, that's the difference in the y values of any 2 points on a line. Run, that's the difference in the x values of any 2 points on a line. Okay, so rise is the vertical change from 2 points, and then run would be the horizontal change. And then when we put those together, we call that the slope. It's the ratio of rise to run for any 2 points on the line. And then what we have here is different ways of looking at what slope is, okay? There's lots of ways to interpret it. M is the variable that represents slope, lowercase m, and it's the ratio of rise over run, as you can see in the fraction here. Okay, a ratio is like a fraction. That is equal to this, okay? And this is one of my favorite ways to write out what you see to the right here. y2 minus y1, x2 minus x1. This little triangle is a delta, okay? And it stands for change in. So the change in y's over the change in x means I'm subtracting the 2 y values, I'm subtracting the 2 x values. I like writing it this way. It's very neat and concise. And since we are working with linear functions, and we can, if we have a function, replace y with f of x, well, you can also rewrite this as f of x2 minus f of x1, which is the change in the y values, is divided by the same thing, x2 minus x1. So there's lots of ways to look at what slope is. We'll be doing that today. So one way to calculate slope is the slope formula, and that was on the last slide as well. So if you take any 2 points, and you can define them as x1, y1 to represent the first point, x2, y2 to represent the second point, and then m is equal to rise over run, or the change in y over the change in x. So we're subtracting the 2 y values and subtracting the 2 x values. When you're plugging into this formula, it's a good idea to write out the fraction bar and write in your 2 subtraction signs before you start plugging in numbers. It's really easy to forget about that minus sign if you happen to be working with negative values. So like in this example, in the lower left-hand corner, our 2 given points are -3, 8, and 2, -11. So there are some negatives that show up. So when you're plugging in your values into the formula, you put the fraction bar and those 2 minus signs in right away, you won't accidentally forget about a negative or a subtraction sign, depending on how you look at it. So in the numerator, we're subtracting the x values, and our x values are negative, I'm sorry, we're subtracting our y values. My bad. We're subtracting our y values, -11 and 8. Okay, so -11 minus 8. And in the denominator, we're subtracting our x values. And you want to make sure you put them in the same order. It doesn't really matter which one you decide to put first, But once you decide in the numerator or the denominator which ordered pair is going to go first, you have to be consistent and make sure you use the other ordered pair in the same order. So because I took from this ordered pair first and put the negative 11 here, I'm going to have to put this 2 right beneath it. Okay, 2 minus negative 3. This would be a spot where it's really easy to forget about one of those symbols. So if you write in your subtraction sign before you plug in your values, it will help. And then just going back to what we know about adding and subtracting integers, negative 11 minus 8 is the same as negative 11 plus negative 8. If you add 2 integers with the same sign, you add their absolute value, so 11 plus 8 is 19, and you keep the sign that is common between them, so negative 19. 2 minus negative 3, when you are subtracting a negative, you instead add the opposite. So this becomes 2 plus positive 3, or 5. So you're going to have a video here that you're going to watch. You'll have a multiple choice question, another video, another video. This is identify the missing value to make the table represent a linear equation. You had a Delta math assignment last week that was like this. Another video, another video. Over which interval shows a average positive rate of change. So you need to watch the video for this to make any sense. All right, so make sure you're watching the average rate of change video before you try the average rate of change problem. And then describing functions, there's different ways to describe them. And this is like a color-coded example. So for this section right here, section A, it's red. Notice it's going uphill slightly. So it's increasing slowly. And because it's straight, it's a constant rate. For B, it's also going up, but it's much more quickly going up. The slope is steeper, so it's quickly increasing, and because it's a straight line, it's a constant rate. For section C, the green section, it is going downhill from left to right, so it is slowly decreasing at a constant rate. Anytime you have a straight line segment, okay, which most of these except for E, they're all constant rates. Okay, you can find the slope of a constant rate, but this section here, E, well, it's curving, but it's also curving and going uphill. So this is increasing, but because it's getting more and more steep more quickly, it's an increasing rate. Okay, if you have a flat line like part F, this is constant because it's linear, it's a straight line. But because it's not going uphill and it's not going downhill, there's no change. It's not increasing, it's not decreasing. Okay, so you're going to answer a question about that function. All right, so you guys are on student pace mode until the last 10 minutes of class, which will be 11:30, and I'll be giving you feedback on your problems as you try them. And if you're trying to figure out where you're going to start at, it's slide 4. You're going to start with slide 4. So go ahead and go to your Pear Deck, and you're going to be working in there. I think you guys are probably telling me that. Thank you. I heard my little chat going off. So thank you for telling me that. That's what happens when you have like 20 tabs open at a time. Sometimes you forget to click here or there. So anyhow, we're going to find the slope, which means we're going to use the slope formula, which is the change in y over the change in x. And it doesn't matter if I choose to put the y value from the first point or the second point first. It just doesn't matter, okay? But you know, sometimes it might help you to not have to work with negatives, or sometimes it doesn't matter at all. But in this case, this is my x and this is my y, right? So I'm going to put the 6 here first because that's the y's go up top. And then the matching x value is the -9, so that's going to come down here. Notice I already wrote out my formula with the subtraction sign so I don't accidentally forget about it. This is my x, this is my y. And so -9 is going to have to go here. So I have a -9. And then -6 is going to go below. So the two values from the same ordered pair is stacked. That's important. And then when trying to simplify this, you got to think back to what do you do when you have minus and negative? You add the opposite. You add the opposite. All right. So when you simplify it, in the numerator, 6 plus +9, that's 15. In the denominator, -9 plus +6. Okay. So when you add two integers that have opposite signs, you actually subtract and you keep the sign of the greater absolute value. 9 is the greater absolute value, so it's going to be -3. And then when you simplify this, 3 is a factor of 15, and it goes in exactly 5 times. A positive and a negative, when you divide, give you back a negative, so the answer is -5. Our slope is -5 on this one. So that was the correct answer. -5. All right, next slide that you had to do was this slide right here. Most of you got this correct. And it's not letting me scroll. There we go. Yeah, so look at all these 11s. Nice work. You figured out the pattern, and you figured out it was 11. Okay, this one gave you guys a lot of trouble. Over which interval shows a average positive rate of change? So as you're looking at the different intervals, intervals. Okay, so the first one, from -3 to 0. So where is t at? Where's the line at when we're at -3? It's like we're down at, I'm just going to use my mouse, so showing my tab here, -3, we're down here at -3 here, and then to go to 0, which is here. Okay, so I go from here to here. This is decreasing, so the average rate of change is not positive, it's negative, so it's not A. -7 to -4. Well, -7 is here, and so my line is right there. To -4, my line ends up here. So we're starting on this part of the blue line, going down, 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 down to here. That's also decreasing. That is not an average positive rate of change. -9 to -5. -9 is here. -5 is here. Also, again, this is decreasing. Even though this little part here goes up, it's positive for a little bit, but ultimately it's decreasing and negative. The last one must be it. +4 to +8. +4 on the t-axis is here going up to my line. So I'm starting here and then following this blue line until I get to where 8 is. So I'm increasing. This is positive rate of change. So the answer here that is correct is D. D is the correct answer. And then there's a little bit of confusion here. So constant rate, you know, that means you have a straight line segment. If it's constant without the rate, there's no change. When there's no change, it's flat, okay? So here it says, is the shown function increasing or decreasing? You can also think about slope, okay? What is the slope of this line? Is it a positive or negative slope? It's going, if you start over here, you're right above 1,000, and as you move along time in months, the balance is going down, okay? We started here at 3 months with 3,860, looks like dollars in a balance of an account. And then as time progresses, down here, oh wait, that's not 3,860. That is the ordered pair. Okay, sorry, that's the ordered pair, 3,860. And then we end up at 8,585. Yeah, that confused me because that looked like a number in the thousands. All right, but this is decreasing. This is decreasing. And a lot of you figured out that it was decreasing. Some of you put increasing. Some of you had constant. The rate of change is constant because it's a straight line, but it's not staying constant.